Welcome to Cheesemake by Roma Dimitri. Today I want to show you how I transformed this hideous receptacle cover into something a lot more presentable. It's a two-part design that works in either orientation and has a high service temperature. In the problem chapter, I'll review exactly what went wrong and how this came to be. In the solution chapter, I'll explain my design decisions and experiments with materials. If you're curious about my tooling, it's Blender and Snapmaker. Be sure to check out my workflow video for more details. This project took about 2 weeks from design to completion, and I think it was a great success. Having said that, let's get into it. Let's go! Problem. I am building my dream garage. The plan was to install two 50-amp receptacles for a welder on either side of the garage door. My electrician installed 4.5-inch boxes, which were appropriate for my requirements. I then installed insulation, sonopan, and finally drywall. The garage is quite big, so this took me a few months. Then the electrician came back and installed these $5 receptacles. Again, these were fine for my original requirements. I want to stress that my electrician did absolutely nothing wrong, and I will 100% recommend them to anyone. But the thing is, I later realized that there's a $50 heavy-duty EV alternative available, and naturally I wanted to upgrade. Just to future-proof the install. My electrician came back and installed this too. Yeah, it worked, but the EV variants are designed for 4-inch boxes instead of the larger boxes that I have. There is an adapter bracket available, but for some reason no plate. At least no plate large enough. Amazon does not offer these, nor does my local electric supply store. This is bizarre, but I know I'm not special. I found others on Amazon who have the same problem. And even the larger plates are commonly returned for compatibility issues, which I'm going to assume is due to the size. One option was to rip out the drywall, sonopan, insulation, and install a smaller box. But after putting months to put all that in, I was in no mood to do it again. Instead, I decided to print my own solution, so let's get into that. How did you solve it? Solution. I want to tell you about the design iterations and materials that I went through. I used Blender and I had 9 revisions. I had 2 receptacles that I needed to print covers for. I assumed they were identical, but I later realized that one of them was rotated 90 degrees. I was aiming for perfection, so this forced me to adjust my design halfway through. When I first started, I quickly realized that keeping the metal bracket and printing my own plate would be troublesome because I'd have to print some sort of supports. Because of course, gravity is a bitch. So the goal became to replace the bracket and the plate in one strong piece so that it can all sit flush on the wall. The design iterations were at first physical, but I also experimented with a few materials. Let's get physical. Let's get physical! Revision 0 was 1.2 millimeters thick, which is just thick enough not to fall apart and figure out if I got the screw holes in the right position. By revision 4, I had the dimensions just right, and this included overall width, screw positions and diameters for mounting to the box, as well as screw positions and dimensions for mounting to the receptacle itself. By revision 6, I realized that 6 millimeters thick would give me adequate strength. I had recessed screw holes for round head screws at the time. I did not love the look, but it worked. I was getting ready to wrap up the project, but then I noticed the second box on the other side of the garage. It was rotated 90 degrees. Again, I just spent months working on the drywall and I was in no mood to rip it out just to rotate the box. So I decided to make a second variant with the outer screw holes rotated at 90 degrees. It worked, but the fact that these screw holes were not oriented the same on both panels was starting to drive me insane. So by revision 7, I modified the design to use flathead screws instead, hoping that this would at least calm me down. It helped, but it wasn't enough. Revision 8 was the aha moment. This is when I realized a 2-piece design will solve all my problems. This might not seem like much, and in hindsight it was obvious, but it's moments like these that make me feel true accomplishment. I am really proud about this one. It brings absolute joy to my heart. The rear bracket has 2 sets of screw holes on the outer edge. These solve for the orientation problem. The 4 holes in the middle are pass-through holes to allow the front panel to grip the receptacle. With the front panel attached, only 4 screws are visible, and it's a very clean look. Since 6 millimeters worked well in the one-piece design, it only made sense to split that in half and try 3 millimeters a piece for the 2-piece design. 3 millimeters did sound a bit thin, but I had to try it. In revision 9, I confirmed my suspicions. 3 millimeters was slightly too thin and flexible. The 50 amp plugs are quite large and I wanted to avoid any weakness. I beefed the design to 4mm apiece and that was it. I was really happy overall. It was very sleek, had nice curves, and was kind of minimal, so you don't really notice it unless you're looking at it. Materials. Materiali. Experiments with materials. I had lack of familiarity and wanted the best possible option in terms of color and service temperature. The whole point of a $50 receptacle is to be able to withstand high temperatures. I'm not sure what those temperatures are, but I assume it's under 100 degrees Celsius. PLA. PLA is great for drafts, but only has a 50 degrees Celsius service temperature. It's not good enough. Nylon with carbon fiber. This is my go-to material, so naturally I started with this for my final prints. It comes out pretty cool in a dark gray color, but after sanding it starts to get white and sometimes it's really tough to wash that dust off. So that was a bit of an issue. The service temperature of my filament variant is about 80 degrees Celsius. That's not bad, but I think we can do better. Nylon. I decided that I wanted white plate covers and nylon would be a good place to start. Nylon has a service temperature of 90 degrees Celsius and I thought it would be easy to print, especially due to my consistent success with the nylon/carbon fiber filament. After a couple days of tweaking my settings and consistent failures, I decided to try something else. It didn't stick, it warped and had poor layer adhesion. I knew with more time I could get it to work, but I wasn't loving the color either. It was a transparent white and I wanted something more solid. ASA. Next, I tried ASA. ASA has a service temperature of 100 degrees Celsius and is an absolute pleasure to print with. It sands very easy. What more can you want? Well, the whitest ASA I could find had this off-white beige look. I like the look, but I have other white plates in my garage, and when compared side by side, they just didn't match up. It was really too bad. At this point, it occurred to me to just look up the material that store-bought plates are actually made of. That's next. Polycarbonate. No, not single carbonate. Polycarbonate. This is the material I chose in the end. It has a service temperature of 120 degrees Celsius, prints a nice white, and has a somewhat transparent quality. It's relatively easy to sand, not as easy as ASA, but that stuff's almost too easy. I do need to mention that it took me a few attempts to get this right. No matter how I set my printer settings, I always had too much oozing. The oozing would eventually turn into a ball and after about 2 hours get stuck to the print. And because the oozing takes so long and that nozzle's so hot, it actually burnt and turned a slight brown. If I left it alone, the ball would fall off, but it left brown streaks between the print layers. This was not the look I was going for. The rear bracket was taking about 18 hours to print at 0.12mm layer height, and checking it every 2 hours was not realistic. I decided to use a 0.2mm layer height instead. This reduced the print time to 12 hours. I then set up a torture alarm, like in the show Lost, to go off every 2 hours so I can push the button. Well, specifically, I would pause the print, clean the nozzle, extrude material, and resume. I had never tried to pause mid-print before, but on the Snapmaker it worked flawlessly. Screws. Let's talk about screws for a minute. There were two types of screws involved. The first was 8-32 stainless steel machine screws with a flat head. I used 2 inches because I had a sonopan layer, but you can probably get away with 1.5 inches. The second had a 6-32 thread at 3¼ inches in length. Also stainless steel machine screw with a flat head. For some reason, the 2-inch stainless steel screws were not available at my local hardware stores, so I had to buy them online. I found some pre-painted white ones on Amazon for the shorter ones, and those look fantastic. Conclusion. So let's summarize. We started with something that looked like this. It was not exactly pleasant to look at. And ended with this. An amazing 2-piece design that covers the screw holes and looks just pretty sleek. We achieved correct fit, high service temperature, and improved aesthetics. Disclaimer. I am not a doctor. I'm not sure if this will technically pass electrical inspection, so do this at your own risk. And if you do know, leave a comment below. I will also leave a comment below once I get a clear answer. But expect to wait a few months because I have some things I need to finish before my ESA inspector returns. 2 weeks total time for design tweaks and material experiments is quite good. And the white screws look pretty sweet too. Overall, I'm gonna rate this project a tremendous success. I'm really happy with the way it turned out. Thank you for watching. I hope you found this informative and I'll leave a link to the model below. If you have any questions, comments, concerns, just leave a comment. Peace outside and enjoy the rest of your day.